Hello, folks. This is the lab presentation in week 8 of the course, and it would have been delivered in person on July 8th. What I would like to do is a problem on a gearing mechanism, a very simple gearing mechanism. So we basically have two gears that are engaged together, and there's a third one, which is a rack and a gear basically engaged together. So what we want to do is here are the specifics of the problem given. Although some of these variables have nothing to do with actual dimensioning of or actual behavior of the mechanism, gearing mechanism, for example, the, the, the depth of the shaft or the depth of that, the thickness of that plate, etc. But the only two things that are important is the radii of these two, actually the ratio of the radii or diameter, because it has to do with the gear teeth, okay? And the ratio will tell you how they actually the gears interact with each other, and that's pretty much it. So the radii of these things are important, but that's all. And the one after we do the problem and basically create a animation cartoon, we're going to put some physics into the problem. For example, we're going to say, okay, suppose that the pinion, the small gear, is turning at 120 RPM. What is the velocity of the rack as a function of time? Obviously, it's a constant, but we're going to plot it. Okay, so let's go ahead and actually do this problem. I have a product file here. Immediately, I save it. File, save management, save as. This is the folder. Let me see, on the desktop, I have a folder called Katia something right here, stuff. Yeah. So we're going to go and create a new folder. So this is going to be gearing mechanism, and it is intended for the lab on July 8th, which is administered by the GAs, by the way. Okay, so we're going to put it there. Let me first do the base. So we say okay. So insert, insert, and the base is actually this wall that you see here. Okay, so it's 6 by 4.5. So insert a new part in there, and I'm going to call this thing right-click properties, base, base, and base. Okay, let's make it. Double click on base here so that you go into part design on a convenient plane, on that vertical plane. I will sketch a 4.5 by 6 inches long rectangle. So this is going to be 6, and this is going to be 4.5, 4.5. By the way, this problem can be done without using the gear icon or rack icon in the mechanism design. But I want to show you how those icons are used to do this problem. Okay. All right. Let's create two circles here, one over there and another over maybe there. Okay, one thing is note that the diameter of these are 0.5, 0.5, and this one is also 0.5, 0.5. Okay, they're 2 inches apart. So dimension from here to here. For once, I'm trying to do all the dimensions that I'm giving you. And then this point, I believe, is halfway, right? It's halfway. Yeah, 3 inches. Okay, very good. 3 inches. So dimension between this point and that is 3. One thing I noticed that the dimensions that I'm giving you actually these are the diameters, so the radius is 0.25. So these are totally irrelevant, but we're going to stick to those dimensions for once. All right, exit. And then we pad this thing by something that's totally unrelated to the behavior of the mechanism, but I'll make it, how about 0.5? 0.5. Very good. Okay, so we go to the product, click on the floppy so that everything is safe. And I'm going to insert the pinion. The pinion is the smaller gear. Usually pinion are referred to the smaller gear, which is the one on this side. Okay, and the diameter of that smaller gear is actually 1 inch. Okay, insert a new part in there, and we're going to make this thing pinion. Right click properties. What do I call the small gear? Okay, small one, small gear, small gear. All right, let's go make it. Double click on this. All right, so on a convenient plane, on that plane, I will sketch. Why don't I project that circle to make my job easier? There we are. And look at the view from the front. And then I make a circle concentric with that. And the radius of that circle is the radius of the pinion, which is 0.5. Or the small gear, which is 0.5. So that's going to be radius of 0.5. And since I want to make one end to go in one direction, the other end, the other circle to go in the other direction, what do I use? Multipath. So exit. At the end of the day, you have to create this the way you want it, the way it's easiest for you. I'm trying to show you some new stuff possibly. Okay, so this is the big circle. Let me make it 0.5. 0.5, let's see. Yep. And this is the one that goes in the other direction, so I'm going to make it minus 0.75. Let's see how it looks like. Uh, did I make it? Yeah, I did, except that actually I didn't want it to look like this. Okay, so let's go back here to multipath. Let's see now. Let me do the following. Uh, I'm going to make this thing also plus. Okay, but actually make it a little bit bigger. Maybe 1.5. How about that? 1.5. We're going to turn this thing around and put it in the other direction. Okay, so this is a pinion, but it has to go in the other. You have to flip it later on. So let's go to the other one and insert a new part. Say no, and this is going to be the big one, the big gear. Let's change it. Change the name properties. Big one, big gear. This is the instance name, and here's a part name, big gear. Okay, good. Let's try to make it. Double click on it. And on that plane, which is convenient for me, I will sketch. Why don't I project that circle? Okay, and normal view, and then draw another circle here. Uh, and the radius of this is going to be 1.5. One thing that's bothering me here, and that, oh, there we are. Okay, yeah, they should be touching, right? Okay, good. So exit. I thought they were not going to touch what they do. So we do a multi-pad. Okay, so this one is going to go by 0.5. And this one, I think I made it 1.5. 1.5. And there we are. It's the big gear. Let's go here and save everything. Go to product. Click on the click on the floppy. It's going to save everything. And now we're going to insert the rack. So we go here, insert a new part. Say no, and this is going to be the rack. Properties, rack, and rack. And let's go make it. Double click on the rack. On a convenient plane, on this plane, I will sketch something that is this. This must be 0.5, if I'm not mistaken. We'll find out. One thing I think I made a mistake here, but that's okay. This distance should have been 2, but I didn't make it 2. That's not a big deal. It's just that my rack is not going to be 0.5. It's going to be a little bit taller. So I'm not going to worry about that. So let's see now. The best thing to do is to perhaps project. Well, actually, let me draw my rectangle. This is going to be the rack, yeah. And let's see now. This line control that line. I'm going to make a tangent to each other, or coincident actually. That's what I meant. And this line control that. Let me actually dimension this thing, see what it is. Yeah, so I don't want it. I wanted this thing to be 0.5, but it's okay. I don't want it. I'm not going to do it like that. So let me cancel this. So my rack is a different size that I actually gave in this problem statement. And these two uh, control these two, and then tangent. Right. So my rack is a little bit. Well, let's see now. Is this 0.5? Is it? No, 0.64. In the problem statement said that this had, well, I wanted 0.5, but it doesn't matter. So I completely forgot about that, but it's working now. So exit and pad it by 0.5. 0.5. Okay, good. So save everything. Go all the way to the top level. Save everything. Copy right there. Okay, so we're going to do the assembly constraints now. First of all, we're going to anchor the back, what I call the base. I'm going to move these apart so that you can see what's going on. So translate in the direction X, there, and there. Okay, let's put them together. Let's put the pinion in first. So coincidence between this axis and that axis, and coincidence between this plane and that plane. And if it doesn't look the way it's supposed to be, we're going to change the configuration here from the same to opposite, or maybe flat. Let's find out. Update. Obviously, that's not what I want. So we're going to go there to that last constraint that I did. Flip the arrows. And now update. Oh, that's a lot better. Okay. A coincidence between this axis and that axis, and coincidence between this plane and that plane. Flip it either from here or from the screen. There we are. Now notice that these are going to become two revolute joints. One revolute for this, one revolute for that. So coincidence between this plane and that plane, and coincidence between this line and that line. And if I update, it's going to go to where it's supposed to be. Oops. Let's see now. something is, let me undo these. Or actually, yeah, let me undo these. Something I probably overlooked. So let's see now. What did I do here? Let me delete this. Let's try it again. So coincidence. How about between, okay, this axis and that axis, and coincidence, for example, between this plane and that plane. I know what I did. I should have selected the back plane of this and the front plane of that, but I didn't. That's okay. That's why there was an inconsistent. Yeah. So actually, this is again not quite. It has to do with those lines. Okay. Let's see now. Okay, I see. Let me delete this. Make it coincidence between this. Oh yeah, this line and that line. And now update. Oh, that's a lot better. Good. Okay, so we're going to get a prismatic joint here, a revolute and a revolute. So let's go ahead and actually save everything. Now this problem can be done if I do the roll curve between this curve and that curve, and a roll curve between this curve and this curve. But that's not how I'm going to do that. I'm going to use the rack joint and the gear joint that is available, icons that are available in CATIA. So we switch to DMU Kinematics, get the magic wand out, new mechanism, mechanism number one, auto create, and I should be getting two revolutes and one prismatic. Let's check it out. Revolute, prismatic. Okay, good. Now, notice that in the kinematics joint toolbar right there, there is something that looks like a rack. See that? It says gear joint. See that? Gear joint. When you click on it, it's expecting you to go and select two revolute joints. So I want these two revolute joints to be selected, see, from the tree. So for the revolute joint one, that's this one. This is the revolute one, okay? And the second one is here. There is the other revolute, okay? Now, the gear ratio default is 1. But if I have radii of these things, I can automatically create the gear ratio. So if I say define, and all I have to do is to select these two. So for example, select this and that, and it tells you that the gear ratio is 0.3, okay? 0.3. So we say okay. Good. And are they going the same direction or opposite direction? Because these are externally engaged, they go in the opposite direction. And we say okay. Now, notice that this gear joint that I created automatically gobbled up these two revolute joints. So next, I want to do a prismatic joint right there. See that? There's the prismatic. When it comes to prismatic, it says, well, sorry, rack joint. When it comes to rack joint, it says select a prismatic one and a revolute one. Well, the prismatic one is already there, but the revolute joint was gobbled up by this guy. So I can always create it. And look at what it says. It says select for revolute joint axis to axis. So this line, right click, hide that line, okay? And the planes are, let's go back here in the hiding, the back of this and the front of that. So I'm creating a revolute joint that I need, and it got gobbled up by the gear joint up here. Now for the ratio, define ratio, and that ratio is basically that circle, that we have that circle was radius 1.5, but you can also go get it from there. Let me bring this in front. Either you put 1.5 here, or you select this. By the way, 1.5 inches is in millimeter, is probably this. Let me use my calculator. 1.5 inches, a calculator on my phone. 1.5 times 24.5, or 25.4 actually. 1.5 times 25.4. Yeah, 38.1. Very good. You say okay, and we say okay. Now notice that the degree of freedom is 1. So the choice is yours. You can make the gear joint angle driven, or you can make the rack joint length driven. So let me make the gear joint angle driven, and let's see now. We have a choice of which one. So let me see. This one, Revolut 1, was, I believe it was, let me see that. Oh no, oh no, we don't want this. Right there. So this is the angle driven joint. We say okay. Mechanism can be simulated. Let's check it out with the sliding bar. So I'm going to change the range to 0 to whatever, so you can see that the small one turns, the big one turns with the physics behind it, and the rack turns. So reset. Let me go back here, and I'm going to go back to this. Let's see. One of these I made. Yeah. So let me make these things. I'll just leave it the way it is. So I'm going to put some physics into this thing now. So we're going to go and click on f of x. By the way, you can create your cartoon, and you can, in the event that you want, for example, you can yeah, let me cancel that for a second. In the event you create a replay, and then go ahead and create a video clip, or if you want to find a trace of something, you need a replay anyway. But let's go put some physics into this thing. You just click on f of x, click on the mechanism, and there is your angle driven joint. I think that angle driven joint is, I'm pretty sure it's this one here. We're going to say add a formula. Now remember, this was 120 RPM, which is 720 degrees per second. 720 DEG divided by 1s per second times time. Okay. Now let's do a, I don't know, maybe a 2-second simulation. So we go to simulation with command, not command, simulation with laws, over a 2-second interval. Okay, and let's actually run it. We're not going to get anything. Basically, we see these things move. That's pretty much it. No physics. That was a lot. 2 second probably was a lot. So let's change this thing to maybe 0.5 second. Okay. Very good. Okay, so let me rewind. And what I want to do is some sensors. So speed acceleration. For the name, just leave it the way it is. Reference product is the wall or the base. And the point that we want is this point. Let me zoom in. This point, for example, we say okay. And let's go to simulation with laws. Activate sensor. See what is it that we want to do. For example, we want the linear velocity or linear speed of this sensor that we created, or speed in the y direction. It's the same thing. Speed in the y direction is going to be the same as the magnitude of the speed. So same thing. So I can do either y linear speed or linear speed because there's only component in the y direction. So up to you. I'll use this, okay? And then we move this thing out of the way. Move this thing out of the way. We play it, and once we get to the end, we're gonna say graphics. So you're gonna get a straight line, okay? I don't know this value. You have to work it out. No, you're learning stuff about gear mechanism, your machine design, gearing systems, and things like that. And you know that the speed of one gear depends on the gear ratios, and which is the ratio of the radii, etc. So you can work it out and check it to see if it makes sense. Remember, if we ask you to do this, okay, you have to screen capture, save it, and then uh, screen capture, you know, put it in the Word document, save it, and give it a name, and put it in the folder that you're supposed to turn in for the final exam or whatever it is. Now, I don't want to go ahead and check this thing. I'm pretty sure it's okay based on what we did, and you can work it out yourself. Good luck, guys. See you soon.